Okay guys, so if you just bought one of these 3018 CNC machine or you want to buy one and you are not sure how to start milling with this, I'm just going to make a guide, very simple step by step to show you how to start making something with this simple CNC machine. Okay, so the first step is just to install the driver for the control board of the machine. This machine is the Chinese knockoff of the Arduino chip, so you just need to search for CS340 driver, and you can just click on the first link here, CS340 drivers for Windows, Mac and Linux. So just click on it and go down, download just here for Windows. So just click on it and save and open. Well, you just unzip this and click on install. Well, here you just click on install if you haven't installed it. I already did, so I just going to skip this step. Next step, what you need to do is just to install a software. Just you can communicate with the machine, like talk to it, make it move, and like start milling, like sending the G code. So you just type in Kendo Gerbil. So here you just click on the first link here and go down. Here I just going to download it for Windows and save and open and just unzip it. Okay, so now you have Kendo installed. If you plug in the machine, you should see that in the ports here you have the USB serial CS340 COM6. Well, whatever the serial port number you're going to give you, here you give me COM6, so that's fine. And now once it's recognized here the machine, you can just click on like open Kendo. Here's the interface of the software. So you just go to service settings and choose the port of the machine, so it's COM6, and just click OK. So as you can see here, you just read the machine Gerbil version of the machine here, and that's it. If you click on double $sign here in the comments, you should see all the parameters of the machine. So now what you can do here, just use the button to move in X and Y, and these buttons to move in Z axis. These are to like 0 in X and Y, and this is to 0 in Z axis. Next step, just you will need to create a G code file so the machine can use that and run and make something. So what I'm going to use here, I'm going to use the free version of Fusion 360. So just type in Fusion 360 free, and here you can see that there's a link for Fusion 360 for free personal use. So just click on that. So in here you can just sign in, create an account, and just download the software and install it. I already did it, so I'm just going to go here and type in Fusion 360 to open it. Okay, so once you install Fusion 360, you just open it and sign in and create a license. So here I have a startup license. So I just click on Sketch to create a new sketch here. And I just going to create something simple to show you the example. So I just going to create a circle. The size, I probably choose like 50 millimeter. Okay, and finish sketch, and go to extrude and do like about 12 millimeter, because I have a piece of plywood is 12 millimeter thick. So that would be very easy to like operate. So I create 12. So here I going to route the edge here. So I click on fillet here and make the diameter 10, 12 or whatever. 10 is fine. And then what I'm going to do is just create a square in the middle, just cut in. So just to show you the example, so I just going to click on this surface and draw a rectangle, but I'm going to do it from the center, so it will be like start here and make a rectangle probably like this, and I finish the sketch. And then I go to, because I'm going to cut this profile into this body, so I just go to body and choose the number 1, body 1, and I go to extrude, and here I just going to do like cut, and object to cut will be this profile, and it should go down this way, and I'm going to do 5mm like this. And here I have a square in the middle here, but as you can see here, I have the corner is like 90°, which I cannot do because the bit is round. I have 3mm bit, so I just going to fillet this a bit. So I just click on fillet here and choose all 4 corner. And I'm going to put 1.5mm. Here you go. And that's it. So now I have very simple shape here. Well, from here you can design anything you want, but I just going to make a simple example to show you quickly. So now to the cam part, I just click on here this button and go to manufacture, and click on setup, and here operation type, just click on milling, and what I choose is that the corner, and you can see here the arrow is X go this way, Y go this way, and Z go this way. So I usually choose this corner to start, and stock I'm going to put about offset on the side is 5mm. Okay, and then top offset I put 0. So now I just going to do like right on top here. So I click OK. That's it. And next step, you have to create the tool. So you click on this tool library. This tool library, you just create the tool once, and it will save the tool in your account here. So next time you like reinstall the software, you still have your tool library online, and you create your tool. So to create a tool, just click on this symbol, create a new tool here, and well, I usually like to make it like run really fast on the for the spindle, so I put like 10,000 RPM. And cutting feed rate, I probably go a bit slow because this machine is not really like powerful. 750mm per minute, that's fine. Lead in, lead out, RAM feed rate, I'm going to go like just like recommend here, so that will be fine. Now cutter, well, you choose the type that you have. I have a flat end mill, so I just going to choose flat end mill, and I have 2 flutes, millimeter, that's what I use. So here you just enter all the parameter of your bit, whatever you buy. So I have overall length is about 50, body length probably let's say 30, and then I have sharp diameter only 3mm. Shoulder length, here you can put like 25, and here is 20. I mean, this is what I have on my bit, so here I put 3. Here you go, I'm done with this. General, you can put a name on this. You're going to put like 3 millimeter flat end mill. Anything. So what else? Sharp. I don't need sharp. So here I'm going to put holder. So I have the ER11, and it's pretty short, I think. So I just choose like ER11, probably, well, whatever is similar to what you have. I think it's about like this. So I just click OK. The holder is shape is not really matter here in this machine because it only goes straight down and it doesn't have much space, so just the cutter by itself is fine. So you just click OK. So here you have the bit just created, so you can close it. Okay, so now you create the tool. First step, I'm just going to machine out this pocket. So I just go to 3D pocket clearing, and I choose the tool you just create. So here, and click OK. So here you have all the parameters of the tool, and you can change it here. So if you change it here, it only affect this cutting operation. It doesn't really affect the setting of the tools in the library. Next time if you open it, you still have the same parameter that you set earlier. So here I just disable this, and I go to here, and I going to choose selection, and choose this boundary. Remember to choose this bottom boundary, not this one, because if you choose this one, it's not going to cut anything. So this one, and tool center is inside the boundary, and well, that's it for this. And here I'm going to reduce this to 4, 2, and nothing here. Because these are small number, so because your machine doesn't have much of the range in z-axis, and here I'm going to put like 0, and just here reduce this number to whatever the machine is capable of. For me, 1 millimeter probably fine, so I just keep it at 1. So I do 5 pass for this 5 millimeter thick, and this I deactivate this. You can leave some stock here, and you can do one last pass to kind of like smoothen the wall, but for me this is fine, so I just deactivate this. And in this I'm going to choose the shortest path so it go faster, and here I'm just going to increase the number a little bit, the angle for the ramp, so it go a bit faster. And that's it. I just click OK. Okay, so here the blue lines are the like way that the bit going to move. So you're going to cut along this blue line, and now you can just do the simulation to see how it look like. So just simulate, and here tools are going to click on transparent, so you can look through the tool. You can deactivate this, or you can choose to leave it, like just to visualize it. So stock, you want to see it, and you can also make it transparent or not. And here I definitely want to go a bit faster, so to see how it cut. Okay, so this look correct to me. So I just close this and go to the next operation, just to mill out this fillet. So I'm going to do adaptive clearing in 3D. So I'm just going to choose the same tool here. I'm not going to change this just to be quick. If you want to do multiple tools, this probably will cut smoother if you use a like bow nose. But for me, I just use the flat end mills because just one simple example to show you. If you want to do multiple tools, just watch my other videos. I showed how I did it. You can do it other way, but I think just the way I did it also just fine. So here I just go to machining boundary. I'm going to do silhouette. What this means, just you're going to cut along the boundaries, just along this boundary of the piece. So tools will be, well, I can choose inside the boundary and additional offset. If I leave 0, it's not going to cut much. I'm just going to leave it 0 for now to show you example. And I'm going to rest machining, yes, from previous operation. So it's not going to cut this part. It only cut like this part because this already cut from previous operation. So now I'm going to move to this, and I also reduce this to 1, no, 4, 2, and bottom high. I don't want to cut all the way down here, so I'm going to cut till here. So it's going to be like 2mm offset. So the bottom high is like 10mm from the top here. So it will be exactly at this line. Here I do the same, 0.1. Maximum roughing step down. This is very important. So reduce this to 1. And now fine step down. If you want to make it like really fine, just follow along this curve. You reduce this. For me, I just going to increase this a little bit so it go a bit faster. 0.2mm. Stock to leave. I'm going to just put 0 for now. So I uncheck this. Okay. Here, just shortest minimum retraction. Same here. Ramping, I'm going to put like 5 degrees. And that's it. I'm going to click on OK. Okay, so as you can see here, it's only generate the first kind of like step down. It doesn't go all the way down here because I didn't leave any kind of like additional offset. So the tools move till here, so you're going to cut till this sign. So it's kind of a 0 on this boundary. So what I need to do is just I'm going to have to add some additional offset here. I'm going to put like -6. So because if I doesn't leave enough additional offset, it's just not going to cut anything out here. Because the adaptive clearing is kind of like swirling like this, so it needs some space to do kind of the spiral. So -6 probably enough for the 3mm tool. Okay, so as you can see, this time is a lot better. It go all the way down here, so that's what I want. So next step, I just going to have to cut this piece out of the stock, so I can just break it off later. So I'm going to do 2D contour and do the same tool. And here, contour selection, I'm going to choose the bottom contour. And I'm going to have to add some tab. So tab are those small pieces, just have to keep this piece like stay in place, stick to the stock, and you can also just break them off very easy later. So here I'm going to put like 4mm. Tab high will be like 2mm, just this kind of thickness. If you leave it too thin, it might just break it off by itself. So I can like, depends on how many tab you want, you can vary this distance. For me, I want about 4, so like this will be fine. So just leave 4 and go to the next step. I'm just going to put like 4, 2.5, and here I want to cut it like all the way down through the bottom of the piece, so I'm going to put minus 0.5 millimeter just to make sure it cut all the way through. Here I'm not going to need to change anything. Here multiple depth is probably important here, because I don't want to cut more than 1 millimeter step down, so I'm going to put maximum roughing step down 1 millimeter. So what this means, just this thickness here, the left over here 2 millimeter, it will do at least 2 pass. And next step here, I don't think I need to change anything here. Oh, here I'm going to deactivate this lead in and lead out. I don't need it, and I click OK. So as you can see here, it go like multiple depth all the way from the top. It's actually not what I want, because this already cut. So what I'm going to do is just I'm going to reduce it, cut only from here. So I'm going to edit this here. I think top high here I can just put minus 10. So here is 12 millimeter, so minus 10 would be exactly this. So I click OK. So now as you can see here, just it only like do this like 3 pass here. So that's also what I want. So let's just simulate the whole thing and see how it works. And go fast. I'm going to deactivate the 2 path here, so make it easier to view. Okay, so now everything look kind of correct to me, so I just close. So here, because you only have one tool, so you can just right click on the setup here and do post process. If not, you have multiple tools, you have to save these two like 2 paths separately. You can just check on this on my other video. I show more details. Here I just going to click on the setup and do post process. Okay, so now in here, what you will need to do for the first time is just you have to choose what type of post processor you're going to use. For me here, I'm going to choose Gerbo /Gerbo. That's the type of firmware, just the control board used to control the machine. So you click on pause. So here I'm just going to name it the circular example piece. Yeah, that's it. So you just save it. Okay, so now when you save it, you can just go and run the machine. But I have to show you something that is, I think, is important. So you go to the location of the NC file that you saved. You double click on it, open it with Notepad or some text editor. So one line that you will need to remove is this one, G28, G91, Z0. This one, if you don't remove it, the machine will plunge into your piece and cut it before you actually start cutting. So that's not good. So I'm going to remove this and save it. That's it. Okay, so now before start cutting, first of all, just make sure just you have this kind of like the machine clamped down to the table. Because of the vibration, it might move and it might fall down off the table, so you don't want that. And also just make sure that your tool is really secured. Don't try just secure it by hand. Use the wrench So just make sure that it's really tight. Okay. And then next step, just you have to fix this stock on it. For the stock size, you only need it to be bigger than what you're going to cut. So to fix this on this platform, you can use this type of bolt and nuts. Just it's come with the machine, but I don't really like this one because it takes some space here, and it's kind of hard to fix it down correctly. So what I'm going to use is this type of mounting tape. So I just need to cut like 4 of the small piece and stick it at the each corner and press it down to the platform. Okay, once you press it down, just make sure it's tight. So the next step, just you will have to open Candle on that computer and find the 0, 0 and 0 point on this. Well, you don't need to be exact at the corner here. As long as you have the Z axis is kind of like really touch the surface. So just go very slowly on the Z and go down slowly till it's kind of like at the surface. Okay, so now I just set X and Y to 0, Z to 0, and now I have to load the G code. Okay, and I can just click send, or I just leave it up a little bit from Z and then click send. Okay, so now the cutting is done. Let me just take it out and show you. Yeah, it's actually quite tight. The mounting tape worked really well. So it looked like this. It's kind of exactly what you simulate on Fusion 360. You just only need to break off this 4 tab and then kind of sand it a bit, like clean it up, make it look nicer. But this, it kind of does exactly what it do on Fusion 360. So that's how you start milling with this machine. And what type of tool path you want to use, you just do some practice, make sure that you simulate it, make sure make sure that it look correct on the simulation first before you actually do the cutting.